Hello, in this video we're going to do two examples in algebra which are of the intermediate level, in other words for years 16, 17 and above. So the first one is if the roots of the cubic equation x cubed plus bx squared plus qx plus r equals 0 are in arithmetic sequence, find a connection between p, q and r. So let the roots be alpha minus d, alpha and alpha plus d. Those are in arithmetic sequence. Okay, so the sum of the roots will be minus b, and adding those numbers together, those roots together, we get 3 alpha. So 3 alpha is minus b. Similarly, the product of the roots is alpha times alpha squared minus d squared. That's got to be minus r. And then if we take the products of the roots in pairs and add them together, that's got to equal q. So we have alpha minus d times alpha plus alpha times alpha plus d plus alpha squared minus d squared equals q. And I've labeled that equation 1. Now, alpha squared minus d squared is equal to minus r over alpha, and alpha is equal to minus b over 3. So substituting into 1, we'll get q equals alpha squared minus alpha d plus alpha squared plus alpha d minus r over alpha, which leads to q equal to 2 alpha squared minus r over alpha. So substituting for alpha, we get 2p squared over 9 plus 3r over p, which equals 2p cubed plus 27r over 9p. And then we'll get cross multiplying 9pq equals 2p cubed plus 27r. And that does the first question. Now, as for the second one, we've got to find the range of values within which the function 2x squared minus 14x plus 11 over 2x squared minus 2x plus 5 exists. So let the function equal k, and then multiplying up, we'll get 2x squared minus 14x plus 11 equals k bracket 2x squared minus 2x plus 5. And then simplifying all that, we'll get 0 equal x squared bracket 2k minus 2 plus x bracket 14 minus 2k plus 5k minus 11. And then for real solutions of x, the discriminant of that equation has to be equal to or greater than 0. In other words, 14 minus 2k all squared minus 4 times 2k minus 2 times 5k minus 11 has to be equal to or greater than 0. Then multiplying out, we get 196 minus 56k plus 4k squared minus 4 into 10k squared minus 32k plus 22 is equal to greater than 0. And simplifying all that, getting everything onto the right-hand side, we get 0 equal to or greater than 36k squared minus 72k minus 108, which means 0 is equal to greater than, dividing through by 36 there, we get 0 equal to greater than k squared minus 2k minus 3, which factorizes as k minus 3k plus 1. So drawn a little graph there of the function k squared minus 2k minus 3, and you can see that it is equal or less than 0 when k is between minus 1 and 3. And so that is our final answer. So there's a correction over here. I'll write it out again. K is between minus 1 and 3. Okay. Sorry about that little gaffe. Okay, well, that does it then. Thanks very much for listening.